Hello viewers, in this topic we'll discuss about increasing and decreasing function. Let y is equal to fx be a real valued function and I be an open interval such that I is a subset of domain of f. Now there are four types of function. First one is increasing function. Number one is increasing function, or you can say non-decreasing. You can say non-decreasing function. How to check this? If I draw the curve of a increasing function or non-decreasing function, it will be like this. See, function increases, then it is constant, then again increases. See, here it is increasing, here it is constant, again increasing. Now let x1 and x2 be two elements that belongs to I. Let x1 and x2 be two elements belongs to I, and we are also given that x1 is less than x2 if it implies f of x1 is less than equal to f of x2, then it is called an increasing function or non-decreasing function. Clearly you can see that in this phase of the curve here, in this phase, this is phase 1, you can see this is x1, this is x2, this is your corresponding f of x1, this is your corresponding f of x2. You can see when x increases, the function also increases. Similarly, this is your x1, this is your x2. Here f of x1 and f of x2 are equal. Therefore we are saying for increasing function or non-increasing function, for x1 x2, if x1 is less than x2, then f of x1 can be less than equal to f of x2. This is an example of increasing or non-decreasing function. Number 2, this is strictly increasing function. Strictly increasing function. See, if I draw the graph, it is like this. This is a case of strictly increases. As x increases, the corresponding y also increases, or like this. In both the cases, if I choose, let x1 x2 belongs to the open interval I, and x1 is less than x2, and also implies that f of x1 is less than f of x2. That is, when x increases, the function f of x also increases. Here in both the cases, the value of f of x1 and f of x2 will be different, and f of x1 is less than f of x2. When x increases, the function will increase. Okay, so this is strictly increasing function. Now it is number 3. This is number 3. This is called decreasing function, or you can say non-increasing function. Decreasing function, or you can say non-increasing function. If I draw the graph of such function, it will be like this. See, the function decreases, then it is constant, again decreases. In this phase, if I select two elements x1 and x2, the corresponding values of function will be f of x1, this is f of x2. Clearly you can see f of x1 is larger than f of x2. In this case, this is your x1, this is your x2. You can clearly see that f of x1 and f of x2 have equal values. Therefore, let x1 comma x2 belongs to the open interval, and you are given that x1 is less than x2, then it will imply f of x1 is larger than f of x2. But in some cases you may get equal values. So this is the analytical method to see whether a function is decreasing function or not. Number 4, it is strictly decreasing function. If I draw the graph, it is like this. The function decreases or like this. You can clearly see this is x1, this is x2. When x increases, the value of f of x also decreases. So let x1 and x2 belongs to the interval I, and you are given that x1 is less than x2. It implies f of x1 is greater than f of x2. You can clearly see the f of x1 is larger than f of x2. So this is the analytical method of checking whether a function is strictly increasing or strictly decreasing, increasing or decreasing. So these are the 4 different functions. Now you can use calculus to check whether it is increasing or decreasing. Now we'll use calculus. This is calculus method. Number 1, for increasing function, or you can say non-decreasing function. If I draw the graph of a increasing function, it is of the shape increasing, again constant, again increasing. See, if I draw a tangent at this phase of the graph, it is like this. At this phase it is like this, and at this phase it is parallel to the x-axis. Therefore, the slope of the tangent at this phase and this phase of the graph will be always greater than 0. You can say dy by dx greater than 0. At this phase, dy by dx greater than 0, and at this phase it is parallel to x-axis. Therefore, its slope will be equal to 0. Therefore, you can say that for increasing function or non-decreasing function, the slope of the tangent at any point on the graph will be positive or equal to 0. You can also write dy by dx is greater or equal to 0. So in case of increasing function or non-increasing function, the f dash x at any point on the graph will be greater or equal to 0. This is for increasing or non-decreasing function. Number 2, for strictly increasing function, strictly increasing function, if you draw the graph, this is like this. At any point on this graph, if I draw a tangent, then it is having slope greater than 0. Therefore, dy by dx is greater than 0. At any point on this graph, the tangent will have a slope greater than 0. Therefore, you can say that f dash x is greater than 0 or dy by dx is greater than 0. This is for a strictly increasing function. Similarly, for this it is also strictly increasing. If I draw a tangent at any point on this graph will have a slope greater than 0. So for strictly increasing function, the value of dy by dx or f dash x is always greater than 0. Now it is third function. It is called decreasing or non-increasing function. Non-increasing function. If you draw the graph, it is like this: decreasing, constant, again decreasing. Now if I draw a tangent at any point on this phase, it will have a slope less than 0, less than 0. You can clearly see the tangent will make an obtuse angle with the x-axis, therefore its slope will be less than 0. At this phase, if I draw a tangent, it is parallel to the x-axis, therefore dy by dx must be is equal to 0. Therefore you can say that for a decreasing function or non-increasing function, the value of dy by dx is always less than 0 or maybe equal to 0, or you can say f dash x is less than equal to 0. This is for decreasing or non-increasing function. Now it is number fourth function. This is strictly decreasing function. If we draw the graph, it is like this. If you draw a tangent at any point on this graph, it will have a slope less than 0. You can see the tangent will make an angle of obtuse angle with the x-axis, so its slope will be less than 0. So dy by dx is less than 0. So hence for a strictly decreasing function, the value of dy by dx or f dash x at any points on the graph will be less than 0. So these are the geometrical interpretation of increasing and decreasing function. Using this knowledge, we can solve any question of NCERT book. Now we'll solve the problems of NCERT book exercise 6.2. Number 1, show that the function f of x is equal to thrice x plus 17 is strictly increasing on R. R means real number. Solution: it is given f of x is equal to thrice x plus 17. Now if I find the value of f dash x, that is if I differentiate respect to x, I will get 3 into 1 plus 0. For x its derivative is 1, for 17 it is 0, so I am getting f dash x is equal to 3. For all x belongs to R, this value will be always greater than 0. See, 3 is always positive. So for any value of x belongs to real number, if I put the value in f dash x, I will have 3. 3 is positive. Therefore your f of x is strictly increasing. Strictly increasing on R. Now question number 2, show that the function f of x is equal to e to the power twice x is strictly increasing on R. You are given that f of x is equal to e to the power twice x. If I differentiate e to the power twice x, I will get f dash x is equal to e to the power twice x. For e to the power x function, it is e to the power x, and for 2 into x, it is 2 into 1. Since ddx of e to the power mx is always m into e to the power mx, you have to remember this. So now we know for all x belongs to R, the value of e to the power twice x is always greater than 0. We know the e to the power function is always positive for any value of x. Therefore, 2 into e to the power twice x is always greater than 0. Hence, you can see f dash x is always greater than 0. Therefore, you can clearly say that f of x is strictly increasing on R, since the value of e to the power twice x is always greater than 0 for any real value of x. Therefore, the value of f dash x will be always positive. Hence, it is a strictly increasing function on R. Now, it is question number 3. Show that the function given by f of x is equal to sin x is strictly increasing on 0 comma pi by 2. Number B, strictly decreasing in pi by 2 comma 0, pi by 2 comma pi, this is pi, and number C, neither increasing nor decreasing in 0 comma pi. So solution, it is simple question. Given that f of x is equal to sin x, if I differentiate f of x respect to x, I'll get f dash x is equal to cos x. Now, number A. Since for each x belongs to 0 comma pi by 2, the value of cos x will be greater than 0. We know that in first quadrant cos x is positive. So clearly for each x belongs to 0 comma pi by 2, the value of cos of x greater than 0. It implies f dash x is also greater than 0, because f dash x is equal to cos of x. So if cos of x is greater than 0, therefore f dash x is also greater than 0. Hence fx is strictly increasing in 0 comma pi by 2. Now number B, since for each x belongs to pi by 2 comma pi, cos of x is less than 0, because in second quadrant the value of cos is negative. So cos of x is less than 0. It implies f dash x is also less than 0. Hence you can say that f of x is strictly decreasing in pi by 2 comma pi. Now number C, you can clearly see the function strictly increases in 0 comma pi by 2. Again it is decreasing in pi by 2 comma pi. Hence it is neither increasing nor decreasing in 0 comma pi. Since fx strictly increases in 0 comma pi by 2 and strictly decreases in pi by 2 comma pi, therefore f of x is neither increasing nor decreasing in 0 comma pi. In this interval, once it is increasing, then it's again decreasing. From 0 to pi, from 0 to pi by 2 it is increasing, and here it is decreasing from pi by 2 to pi. Therefore in the interval 0 to pi it is neither increasing nor decreasing. Okay, this is number 3. Now it is question number 4. Find the intervals in which the function f given by f of x is equal to 2x square minus thrice x is, number A, strictly increasing, number B, strictly decreasing. So you have to find the intervals where the function strictly increases and strictly decreases. You are given f of x is equal to 2x square minus thrice x. Since we are using calculus method, we need to find f dash x. So find out f dash x. F dash x is equal to, for x square, the derivative will be twice x. So it is 4x minus 3 into 1. So it is 4x minus 3. This is 4x minus 3. Now, if I equate f dash x to 0, it will yield 4x minus 3 is equal to 0, that is x equal to 3 by 4. See, for polynomial function, the domain is real number. You can clearly see this point x equal to 3 by 4 has divided the real number minus infinity to plus infinity into two disjoint intervals. The point x equal to 3 by 4 has divided r into two disjoint intervals as such as minus infinity to 3 by 4 and 3 by 4 to infinity. If you can check, if you draw this table has three parts. First part is for interval, first column is for interval, second is sine of f dash x, and third one is nature of function. See, in these two intervals, first one is minus infinity to 3 by 4, second one is 3 by 4 to infinity. If you take any value less than 3 by 4, the value of f dash x, that is 4x minus 3, will be less than 0. Suppose if you take x equal to 0, it is 4 into 0 minus 3. So whenever x is less than 3 by 4, the value of f dash x is negative. So the function strictly decreasing, when x belongs to the interval minus infinity to 3 by 4. Now if x is greater than 3 by 4, take 1. If I put 1 here, it is 4 into 1 minus 3. This is 4 into 1 minus 3 positive. So the sign of f dash x will be positive where x belongs to 3 by 4 to infinity. So the function is strictly increasing. Now you can say that for x belongs to minus infinity to 3 by 4, your f dash x is less than 0. Therefore, f of x is strictly decreasing in minus infinity to 3 by 4, and for x belongs to 3 by 4 to infinity, the value of f dash x, it implies, you can say, f dash x is greater than 0. Therefore f of x is strictly increasing in 3 by 4 to infinity. You can make this table to see the function increasing or decreasing in the certain interval or not. Now it is question number 5. Find the intervals in which the function f given by f of x is equal to 2x cube minus 3x square minus 36x plus 7 is strictly increasing and strictly decreasing. So you have to find the intervals. So you're given that f of x is equal to 2x cube minus 3x square minus 36x plus 7. Find out f dash x. You will get 6x square minus 6x minus 36. If you take 6 common, this is x squared minus x and minus 6. Now you need to factorize this. If I factorize this, I will get x minus 3 into x plus 2. If you factorize this, you will get x minus 3 into x plus 2. Now equate f dash x to 0. It implies 6 into x minus 3 into x plus 2 is equal to 0. Therefore x equal to minus 2 and 3. You can clearly see for the polynomial functions their domain is real number. You can see the points minus 2 and 3 had divided the interval minus infinity to plus infinity into 3 disjoint intervals. Now the points x equal to minus 2 and x equal to 3 have divided real number r into 3 disjoint intervals, such as first one is minus infinity to minus 2, second one is minus 2 to 3, and third one is 3 to infinity. If you draw the table just like previous question, you will get 3 intervals. This is interval sine of f dash x. This is nature of function. Now the intervals are minus infinity to minus 2. This is minus 2 to 3, and this is 3 to infinity. See, if you check, if you take any value in the interval minus infinity to minus 2, take minus 3, put minus 3 here. This is minus 3 minus 3 minus 6, minus 3 plus 2, this is minus 1. So minus into minus positive. So here it is greater than 0. So in this interval the function strictly increasing. Now in the interval minus 2 to 3, if you take 0, in the interval there is a point 0, put 0, 0 minus 3 minus 3, 0 plus 2, 2, 2 into minus 3 minus 6, this is negative. So it is strictly decreasing, the function strictly decreasing in the interval minus 2 to 3. And similarly for 3 to infinity, if you take 4, 4 minus 3 it is 1, and 4 plus 2 it is 6. Multiply them, the product is positive. So function is strictly increasing. So you can write from this table, therefore f of x is strictly increasing in minus infinity to minus 2 union 3 to infinity. In these two intervals the function strictly increases and strictly decreasing in minus 2 to 3. So this is your question number 5. You can check in the intervals where it is increasing and decreasing from this table. In next video we'll upload more problems of exercise 6.2.